We are Eric, Amanda, and Ivan, and we would like to explain the general phosphorus cycle to you. Seeing as this is the slowest biogeochemical cycle, we hope to explain this quicker than a cycle would take to happen.
It is a rather simple process to understand, so we would like to take the time to walk you through it.
To begin explaining the phosphorus cycle, we will start on land. Rock weathering is the starting point for the phosphorus cycle.
When apatite, which is a rock, not a state of being hungry, naturally weathers, phosphorus is released into the environment and enters the cycle. Roots and mycorrhizae take up some of the phosphorus that weathered from rocks. This is not like nitrogen fixation, though, as this is very slow and not an entirely deliberate process.
Plants need phosphorus to grow and form nucleic acids. Plants and all living organisms need phosphorus to survive. It is one of the 16 essential nutrients necessary for life.
The net primary production of carbon, and thus the growth of the plant, is limited by phosphorus available to the plant. Nitrogen fixation increases with increased phosphorus availability, which also helps plants to grow. When plants die, they are broken down by detrivores, and then the phosphorus is released as organic phosphorus into the soil. The phosphorus is then taken up by other plants.
However, if plants are eaten by animals instead of decomposing, the phosphorus is then taken in by the animal. The animal uses the necessary phosphorus and excretes excess phosphorus back into the environment. When an animal dies, any remaining phosphorus is broken down and returned to the environment as well.
On top of the terrestrial cycling, a big part of the phosphorus cycle takes place in the deep blue sea. Phosphorus winds up in the ocean through natural runoff from land into rivers, streams, and estuaries. Phosphorus runoff happens when phosphorus, which is a negatively charged anion, binds to soil and water carries the soil into surface waters.
Most of the bound phosphorus settles to the ocean floor, leaving only a little bit of reactive phosphorus in the ocean. Eventually, like in terrestrial environments, the reactive phosphorus is taken up by organisms, but is decomposed when those organisms die.
Most of the natural cycling of phosphorus is on land or in the ocean. The cool thing about phosphorus is that there isn't a significant atmospheric component to the cycle. Phosphine, which is the gaseous form of phosphorus, does exist in itty-bitty amounts in the atmosphere, but it's not a significant part of the cycle.
Phosphate dust particles also make up a tiny portion of phosphorus cycling, but it is generally a very minimal part of the cycle. Additionally, there is only one naturally occurring isotope of phosphorus, phosphorus-31.
So now that we have covered most of the natural cycle, we'd like to talk about some of the problems within the phosphorus cycle.
Though the natural cycle of phosphorus is fairly straightforward, humans of course manage to mess things up. With the addition of mining into the environment, there has been a drastic increase in the amount of phosphorus runoff.
This runoff adds to eutrophication and massive algal blooms in waterways. These massive algal blooms wouldn't happen normally because phosphorus is limiting in the environment, but when excess is added, it is less limiting.
One of the other ways humans have completely altered the cycle is by using phosphorus fertilizers in agriculture. The official name of some of the major phosphorus fertilizers are ammonium phosphate and triple superphosphate, or TSP for short. It is used to help plants grow in agricultural fields, but frequently runs off into the waterways.
On top of being used in agriculture, phosphorus is used in a variety of other processes. Phosphorus in the elemental form is called white phosphorus, and can kill you if you accidentally swallow even 50 milligrams. It also will catch fire as soon as it comes into contact with oxygen.
Now that we've talked about how awful phosphorus is, let us bring things back to a sunnier place. Phosphorus can be used as a method of fighting forest fires, as it's a flame retardant. It's kind of ironic that phosphorus is used to stop fires, as phosphorus is also used in match strikes to start fires. It can also be used in cleaning products for that clean dish sparkle.
Phosphorus is also used in metal treatment, pharmaceuticals, water softening in drinking water, antifreeze, oil drilling, synthetic rubber production, various food products, and wool dyeing. Needless to say, there are endless uses for phosphorus.
Thank you for watching our explanation of the phosphorus cycle. Now you know.
Now you know.
created using Powtoon.